Yeah, okay, so I'm Craig Gallen. So basically I worked for Nortel for a load of years where I was a product manager and contributed greatly to them going bust. And as a result of that, I left and did some doctoral research looking at open source and telecoms, and that's how I got involved with Open NMS, and I've been doing Open NMS stuff ever since. So that's probably all you need to know about me. So how many people here have heard of Open NMS before now? Oh wow, fantastic. How many people have downloaded it and tried to use it? A few. How many use it in production? Anybody? Oh, wonderful. Great. So that's actually one company and one other. Very good. Okay, well, for some of you this will be stuff you've heard and know already, but hopefully I can give you a bit of a flavor of where we're going with the project as well in the talk. I'm happy to take questions at the end, but if there's anything burning as we go along, please jump in as well, and we'll talk about it. Oh. I'm not going to go anywhere with that. Right, okay. So my principal objective of this is, for those who don't know, is to give you an idea of what the difference is between Nagios or Zynga and Open NMS, because that's the question that everybody asks me whenever I sort of talk about network management. They say, oh, using it or whatever, and they don't necessarily know the difference. So hopefully by the end of this, if you know Nagios and you know Zynga, you'll have an understanding of where Open NMS plays and what's different. I'm going to talk a bit about the community and how the project works, how it's formed, and then I'm also going to talk then a bit about where we're going with Open NMS and the technology that's in it. So we like to say Open NMS is the world's first enterprise and carrier grade network and infrastructure management platform developed under the open source model. First, because it started about 15 years ago and is only about one or two numbers away from Nagios in terms of when it actually started. So both projects are around about the same age and have been going the same time. And it's a long time in terms of technology. And I think anybody who sees Open NMS of 10 years ago and Open NMS now would say actually they're very, very different in terms of what's under the hood. But the fact that the project's been going for that length of time means that there's a very large community of users and also a lot of experience has been gained as we've developed the project. Enterprise and carrier grade, this is where Open NMS wins out. You can run it on your laptop, you can use it in a very small infrastructure and it works fine. But really the people that come to us for help are people who've got very large infrastructure. And typically the reason why they've come to us is they've been, some other vendors come along and said, it's going to cost you £1 million to manage these thousands and thousands of elements you've got. And they've looked at Open NMS and saying, well, here's a model that doesn't charge you more depending on how many devices you've got. And so we've got a very large network and therefore it's beneficial to us. So those are the sorts of people that come to us and use it. It's written in Java. There might be a little bit of other stuff under the hood as well, but mostly it's in Java. And it's packaged for pretty much any distribution that you want to run it on. And the real key thing is it's proven resilience and scalability. In terms of the community and the people around it, we have a very active user community. We've got about 40 people who can commit code. They're members of what they call the Order of the Green Polo, which basically means that we give them a green polo shirt once they get the permission to commit. And that's a typical open source thing, peer-led group, which is self-electing. It doesn't, the Open NMS group can't appoint people into that. It's genuinely an independent open source community which actually develops the code and sort of does a QA on it. So it's governed by the OGP. We have a foundation in Europe which runs the user conference basically. And, but the actual assets of Open NMS are owned by the Open NMS group, which is a little company of about 10 people based in North Carolina. And then there's numerous ones of us like myself who also make a living out of Open NMS who are sort of around the world doing stuff with various customers. Large number of sort of fairly high profile users. We have about 4,000 downloads a month, so we really don't know who is using Open NMS. It's always a surprise when people come up and tell me they're using it. But in terms of high profile customers, the people that actually pay us money, these are the sorts of people we're talking about. And I'll talk a little bit more about one or two of them in a bit. Yeah, in fact, now. So Airspeed It's a classic example. They're a wireless provider in the Republic of Ireland. They basically provide point-to-point links for large network. The HEAnet, which is their sort of equivalent of Janet. The academic network in Ireland is run by them. And they use Open NMS basically as their primary network management platform for managing that sort of size of network. Now, the interesting thing about it is that wireless networks tend to have a lot of very strange things, and Open NMS is able to adapt to those things easily. They can modify it to do what they need to do with those devices, which is quite often difficult if you're just using a sort of standard off-the-shelf system. Arqiva is another good example. They broadcast the BBC in the UK. Now, Open NMS is by no means their primary OSS, but again, they have a lot of things that they need to manage which don't fit easily into this primary OSS. And since their primary OSS vendor usually charges them, something like £3,000 for a new agent for a device, if they can use Open NMS to do that, and they can do it for free, and they can do most of the configuration themselves, they get great benefit out of it. So another good use case. If you go online and look at the UK NOF 30 talks, which were done in January this year, Donald Cunningham and Ian Jarrett actually say quite a lot about their use cases on this. I've just taken a couple of slides out of their talks just to show you. Juniper Networks, another big user of Open NMS. Open NMS in that case is embedded within Junos space. They basically wanted functionality they didn't want to make themselves. They could get that functionality from Open NMS. And this is very much part of the direction Open NMS is going. We want to be the commodity platform of choice for service assurance. And then we want vendors to be able to build their bespoke, specific stuff on top of Open NMS that's specific to individual equipment. That allows them to build element managers without having to do a lot of the guts of fault and performance management that everybody has to do. Why would I do it again when I can get it, cheaply using another system? Shadow NMS is another interesting example. Two gentlemen here from Shadowcat. They're basically using Open NMS as the engine underneath the service that they're offering to their customers, whereby they use Open NMS to manage their customers' websites, and they provide it as a subscription service. So again, we have other users of Open NMS who are doing the same sort of thing. It just gives you another example of how Open NMS can be used in a real environment. So I want to talk a little bit about where we're going with Open NMS in terms of the distribution. So if you've looked at Open NMS lately, we've now introduced this concept of Meridian and Horizon. We've only introduced this in the last month or so. Basically, the reasoning has been that up until now, we've essentially had only one stream of Open NMS development. And then for customers who basically are using the system in production, they don't want it to be upgraded, every 3 months. They want long-term support, and they want something that's stable. But on the other hand, for developers who are wanting to do new things and wanting to pick up new features, or customers who are just rapidly wanting to move forwards, they want something that actually keeps up with the development stream. And so similarly to Red Hat, we've moved into this model where Meridian is our equivalent of RHEL. It's the enterprise version, it's got long-term support, and all of our support customers would sit on that. But if you download it off the internet, then you get Meridian, which is our rapid development, and the sort of release comes out every 3 months in Meridian. And there's no backporting of bugs or features to previous releases. So we've moved to that model. It's somewhat new. If you've been using Open NMS to date, you might not have seen this, but those are the reasons. Okay, so let me talk a little bit about what Open NMS does. And to introduce that topic, I wanted to talk a little bit about what it means to manage a next generation service. And this just gives you a very broad view of what that might mean. In terms of managing a service, you as a user, obviously may not have access to all of these layers, but it's possible that you do. So you've got the network cloud, you've got the physical infrastructure, you've got virtualization, and in that virtualization you may have multiple VMs supporting the same service. So services represented by a URI at some point, and then above that there are applications that are taking access to that service through the network. Now, this is obviously a kind of classic Web 2 model, and it's exactly what Open NMS is designed to manage. We can manage at every layer in that infrastructure. So it's possible for us to take a vertical view of everything, or it's possible for us to have Open NMS just in one or two components of this, focusing on a particular service or focusing on the underlying infrastructure. When people think about Open NMS, they tend to think about it as being just network management, SNMP, but that's far from where we are now. We do the whole stack from top to bottom, and I'll show you a little bit about what that means in a bit. So to introduce that topic, you obviously can't read this very well, but if you download the slides, you'll be able to see it better. It's basically a process map for a large service provider, and it gives you an idea of the various parts of the organization that do different things in the service provider. And the basic concept of this is that what we have here is resource data collection and distribution, which is really what Open NMS does. And then you've got various different parts of the organization that make use of that data. And where Open NMS is very strong is in making available data for specific purposes to different parts of your organization. So you can have customers looking at Open NMS, you can have account teams looking at Open NMS, you can look at service trouble management, you can look at resource trouble management, and you can do long-term trending. All of those different functions within your organization can have different views into Open NMS for those functions. And part of the stuff that we would do if we're going in and consulting with somebody who's doing a large installation is trying to help them work out what Open NMS would do for them in their organization as different bits of the organization use Open NMS for different purposes. The same is true for performance management. So we do fault, obviously, but performance management, we're now measuring performance data and generating SLAs, generating reports, and again, information for long-term trending on performance. So we bring together fault and performance, and if performance goes outside certain bounds, we will generate a fault and then provide that up to somebody to actually escalate and do something with. In terms of where we get the data from, so I was talking about being able to cover the whole stack. We can pick up data using many different protocols and technologies, far from just SNMP. We can even log in to a web page, scrape the web page, pull the data out and use that. So if you had a load of very low cost routers out there just at the edge DSL, we can even log into them, pull the data out and do something very quick and dirty that way. We have this concept of remote pollers. So Papa John's Pizza is a very good example where they've got 6,000 shops in the United States, each of which has a remote poller from Open NMS. And that, from the shop's perspective, looks back to the point of sale systems at their central data center and shows the network managers within Papa John's whether a shop is unable to connect back to the data center. And it will look at all the services that the shop would use. So it would look at everything, of the different point of sales applications. It will do synthetic transactions against the application on a continuous basis and give them a view from the shop's perspective of the availability of that service. And it does it for all 6,000 shops. So these sort of remote collectors, can be installed on mobile devices. They can be installed even on your, just using a browser. You can pull it down into just a desktop machine very easily to install. So it's possible to use this in lots of applications where you want to have a view of how well your service is doing from a remote location. For IPv6 Day, for instance, we asked the Open NMS community to install multiple remote pollers around the world. And we were able to see from various different countries around the world the availability of IPv6 on that day. And it was testing DNS, it was testing lookups against Google or lookups against Facebook and all the big players who were playing in IPv6 Day. And we were able to see on a global basis how well those services were doing from the end location. That's the sort of thing that capability is intended for. So what about scalability? Well, if you were at Google's talks yesterday, scalability in terms of Google is not what Open NMS does. So I'm not going to pretend that we're at that level. But in terms of scalability for a service provider, large ISP, or for particular services within a service provider, we're definitely at that level. And you can measure scalability in multiple ways. I've talked about the number of users that can use Open NMS for different purposes, or the ability to send reports out of Open NMS for different purposes. So that's user scalability. But then in terms of the actual underlying engine, we've got Swisscom. Basically, all of the hotels that Swisscom manage in Europe who've got Wi-Fi, all of those Wi-Fi endpoints are managed by Open NMS. So 60,000 devices on a single instance of Open NMS covering the whole of Europe. New Edge Networks in the United States, 1.2 million data points every 5 minutes from their data center. So that's performance data that we're collecting. And that data has been rendered up by New Edge for their customers if they call up a report on performance data. Wind is a large mobile operator in Italy. Their use case was for their core network where they had devices with very, very, very large numbers of ports. The key point here is that most network management systems couldn't discover that number of ports on a device in any reasonable length of time. Open NMS can be pointed at a device and will find all 32,000 interfaces within about half an hour. It'll self-configure, and you can set up policies around that as to which interfaces you want to monitor, which interfaces aren't important to you. But it allows you in a very large network infrastructure to be able to quickly provision or understand what the devices are. Savannah River Nuclear Solutions looks after all of the US's plutonium. I don't know why they have 2,000 events per second. It might be Geiger counts, who knows? But so again, you know, just events coming into OpenNMS. In this case, it's just syslogs. Gives you an idea of the ability to pick up data quickly. And then remote monitors I've already spoke about in terms of Papa John's. So different sort of dimensions of scalability to give you an idea of where it fits. I talked a bit about passing data out. So we've got multiple different views that people can use. You know, we can generate reports, and those can be emailed out on a regular scheduled basis or on demand. And we've got a report engine that can sort of generate this. You can customize them to do what you want. And then you've got various UI tools as well. In terms of sort of the user dashboard, and this is a new feature that's come in basically in the last 6 months or so, we now have the ability to have a rotating wall board. So like you go to every network management sort of NOC and you see, you know, these wall boards, and they mean absolutely nothing basically. They're just there as eye candy for somebody visiting the NOC. There's nobody actually uses them. Well, you know, it may well be true of Open NMS's wall board as well. It will fit the same fate. But what we have added into it is the ability for it to rotate through multiple displays. So you can set up the set of displays that you want the wallboard to show. And if something happens on a particular display, it'll stick. So it's possible, and that's a good visual education. So if somebody's sort of working in the NOC and they notice in the corner of their eye, this display has stuck for some reason, then they can dive in and say, oh, well, there is actually a real problem here. I need to go and look at it. And then obviously we do a dashboard type display, which is the same sort of thing, but for a desktop perspective rather than a sort of big wallboard perspective. Okay, so topology and maps. So we can place devices or we can place locations, data centers or whatever, on a map. In this case, it's OpenStreetMap. We can use any tiling engine basically to place locations of devices. That's a sort of physical GIS view of stuff. But then we can also, and this is again new in Open NMS, display topologies which are automatically generated. And this is actually an Ajax-based capability. So a lot of the rendering is being done actually within your browser. So it's been offloaded from Open NMS. The idea is that you can click on a device and see all the related devices connected to it. And so if you have a fault, you can see every other device that's been affected by that fault. And you can quickly navigate between devices around the display and see what's going on. This was developed as part of the work that we did for Juniper Networks. So this is the sort of stuff that's embedded in Juno space, but it is standard within Open NMS. Now the key thing with this is that all of those links are discovered. So we do layer 2, layer 3 discovery on devices where that's possible. And also in the terms of our integration with VMware, we can pull out from VMware what physical hardware there is and what VMs are running on it, and then basically give you the same view, showing you physical hardware and logical hardware, sort of allowing you to navigate around your virtualized infrastructure. And that same capability now is being worked on for the other sort of standard virtualization infrastructures, OpenStack and that. as well. So there's work going on in that. Now, dashboards are a big thing now. A lot of people are moving towards wanting to be able to create their own dashboards. And rather than sort of limit people to what dashboard technology they want to do, we've taken a different approach. We've basically said, well, Open NMS will have its own dashboard and that sort of stuff. That's fine. But we also expose a REST API that allows other people to create their own dashboards. So this is an example. The code is all available on GitHub. This is a Grafana dashboard that's been written. And again, if you click on that link, you can actually see a working version of it. That uses the REST API off Open NMS. So if you want to do your own dashboard, roll your own, include it with other data you're getting from other sources, the REST API will support that off Open NMS, and you can build that dashboard yourself. So where are we going next? Well, this sort of gives you an idea of our sort of vision for Open NMS. Sorry. I'm trying to knock everything over. I am, yeah. I know. Just step backwards and into the screen. That'll look good on camera. So at the moment, the reality is, we have Open NMS, which in itself can be distributed across multiple servers. So if you've got a very large installation of Open NMS, you might have 2 or 3 servers that are actually doing that, but it's still a single Open NMS instance. And the reality is that it's still difficult to do backup and restore on that, and reliability remains a problem, which it does for most network management solutions. This is not something sort of unique to Open NMS. It hasn't really been architected in its present form to make it very easy to distribute and do failover and recovery. So that's part of the stuff that we're obviously working on, getting away from just hardware solutions to that, towards something that's actually baked into the system. And again, as I said, we have these remote pollers, which is fine, but they're limited in the data they can collect. It would be much better if we had remote data collectors that could collect any data that OpenNMS wants, that could run anywhere in the cloud or in any environment that you wish, and then send data back to OpenNMS. That would be a much better solution for us going forwards, and be much, much more scalable. So that's the direction of movement. But in doing that, we obviously don't want to throw away all the good stuff that's already there. So, there's been years worth of work that's gone on to pick up all the SNMP MIBs from all the devices we've got, to do all the JMX data collection for the devices we do with JMX or whatever. We don't want to throw it away. So it's important that we keep the ability to collect all that data in a very scalable way, keep the ability to learn what a device is, but at the same time be able to distribute that capability around and report back to the same central data center what's going on. And this is really what this architecture is about. So we're introducing, and again, if you look on GitHub, you'll see a project called SNEPO, which is OpenNMS spelt backwards, which is basically OpenNMS running in an OSGI container, but just doing the data collection. And so that represents a small module you can install anywhere, which will get its configuration from the central OpenNMS servers, but will then start collecting its data. If it's disconnected from the network, it will store it locally. Once it reconnects, it will send it back. We're introducing the use of proper sort of ESB for sending data around, so service mixes are sort of engine of choice at this point. But the idea being, again, that we're not just doing sort of point-to-point communications, but we're able to fit into a large ESB infrastructure, both for configuration messages and for the performance or fault messages that are coming back as well. And then in terms of big data, because our sort of limit to scalability at the moment, one of our big limits is, again, like RRD tool or Asinga, we use RRDs as our primary data store at the moment for performance data. That works very well, it's very effective, but the truth is that it's difficult to replicate across data centers, those data sets. And also, you're limited in what you can do with that data because it's compressed in various ways. Fine, I'm nearly there. So we want to move to using a NoSQL backend store. And so our first sort of attempt at that is something called Newts, which again is available up on GitHub. The sort of newfangled time series data store based on Cassandra. And that will allow us to replicate the data storage around multiple Open NMS systems with the remote end data collectors picking up data and sending it in. So essentially what that allows you to do is within the cloud, so imagine this is just a simple service that's running in the cloud, several different VMs within its own address space. you can actually have an Open NMS SNEPO or even just a remote poller sitting within that address space, doing whatever it needs to do, and then reporting back to the external Open NMS, which again allows us to be much more compartmentalized in what we're doing in terms of reporting data back. Going the wrong way. Cassandra I've spoken about. The other thing that we're strongly moving to, and I alluded to this a bit, is OSGI modules. So OSGI is a container technology for Java. Basically, the problem we're trying to solve with this is, at the moment, anybody who's trying to do development in Open NMS needs to be a brave soul, to be honest, because you have to understand an awful lot before you can get anything going. And that's just, it's unfortunate, but it's the truth. OSGI will allow people to create bundles that will drop into Open NMS and use the standard API, a bit like plugins for WordPress, and allow us to then have a larger development community doing stuff in parallel with the core platform moving forward at its own speed. So we've already got to this point. All of our web UI now is effectively running in the OSGI container, and we've got multiple modules that we've been writing on top of that to sort of add extra features and capabilities. But there's still a lot of Open NMS that's sort of sitting in the standard daemon structure that it has. But we're reckoning within the next 2 or 3 releases, we'll actually have moved to the point where everything is running within the container. And then a SNEPO will effectively just be a subset of Open NMS running within the container, but a full Open NMS will be all of the functions running in the container. So it just becomes easy. Now that opens up another possibility, which is about license management, which of course for an open source community is saying, oh, why would you want to license anything? Well, the reality is that we want vendors to use Open NMS as a platform. And those vendors typically have proprietary code that's tied to their elements. So, they in reality want to be able to control what software can run in a particular environment, even though the environment itself might be open source. So we're introducing a concept of a license manager, which incidentally, we haven't seen any other license managers publicly available for OSGI containers. This provides basically a full life cycle of generating a license, selling a license, and a user creating a license and installing it on a system for OSGI containers. So if you're an OSGI developer and you're interested in this, I'm very happy to talk to you about that, because it's not an Open NMS specific. It's something that we're developing for our purposes, but which will be generally useful to the OSGI community. And that, we hope, will open up the marketplace, again, for vendors to use Open NMS as their standard platform into which they can drop stuff if they wish to. Now, the other thing that's happening, obviously, in the real world is we're moving to this idea of network virtualization, where basically you don't buy a router anymore, you just buy software that runs in some commodity hardware. That's very much the direction that the industry is going in. And part of our design strategy is to fit into that infrastructure. So to give you an idea of what that means, if you think about Open Daylight, have many people heard of Open Daylight? Any 1 or 2? So Open Daylight is a software-defined network controller, which is itself written in Java, which is running in an OSGI container, and which basically has been adopted by most of the vendors of network equipment as their mechanism for delivering software-defined networking. It's a project that's had a lot of uptake. And so the fact that that's running in OSGI and we're running in OSGI makes it possible for us to do parallel deployments as part of the same thing. So you get the controller and the manager going in at the same time as part of this. So that's the direction of travel that we're moving in, and why it's important for us to be pulling into this OSGI stuff. So I was warned that we were nearly finished, and indeed I am pretty much finished. So I'm hoping out of this I will have been able to, if those of you who are thinking about it, maybe think about Open NMS as a platform you might want to use. Encourage contribution, particularly if you're doing research or anything like that around networking. We think Open NMS is a great platform for you to build upon, and rather than writing stuff from scratch, we'd encourage you to give it a go, become part of the community, and contribute in any way you choose. Any questions?
Have many people done much with Open NMS and, say, EC2 instances? So maybe to pull data from CloudWatch, or just to use it. So you're running Open NMS in your own environment, but you're pulling remote collectors or something. So maybe this SNEPO you call it.
Yeah.
Have people done done much with that?
Well, Snapo is very new, so I mean it's been done for a particular customer, and the use case you're describing is their use case, right? So in terms of remote pollers, yes, we know people have done that, and there are Open NMS itself for sort of providing in images now as well, so it can run in the cloud as well. But yeah, that's the direction of travel. I think where we're sort of sitting with Open NMS is for many data centers have got a mix. They've got their main data center, which is all their own hardware and whatever, and then they burst out to the cloud. And so that's really the sweet spot for us, I think, where people still want to manage their own infrastructure, but they want to manage some stuff in the cloud, as opposed to have everything in the cloud, where the cloud providers do provide a lot of that capability anyway for you. So we are involved in a Catalyst project with Microsoft, which will be demonstrated in Nice at the TEMA Forum, big event this year, which is looking exactly at that problem you're talking about. So I can talk a bit more about that in a bit. Yep.
I tried to use Open NMS a couple of years ago. We've got an existing Nagios setup, and I was looking at using Open NMS at the center to speak to the NRPE daemons on all of our servers, which it does do, but I ran into some, it felt like a bit of a philosophical problem in that it looked a little bit like NMS was more aimed, and they say, hey, lots and lots of devices that are very similar, whereas we had lots and lots of devices that had lots of different checks. Like the most obvious one was we had lots of servers with different websites on, and it looked a little bit like Open NMS wanted to expect to find the same website and all the other nodes, and then the way I had to define a template or anything. And it's quite an open-ended question, but is that am I wrong there? Was NMS the wrong thing for the job, or can it do what I'm looking for?
There's kind of two ways of deploying Open NMS. You can configure the hell out of it to manage a particular service, in which case you'll use all its internal rules engine and all that sort of. There's lots of stuff in there to do correlation and actually give you a configuration that's specific to a typical service. And that works, and that's fine. But it's difficult to do that at the same time as managing a large network. And large networks tend to be vanilla, and they tend to just show you a bit of everything. So I think that the part of my answer to that question is, I would say Open NMS is sort of the high-level thing that gives the first alert, the window into whatever, and you may still have Nagios or whatever underneath that sort of becomes your go-to once you've found your problem. But Open NMS gives you the sort of first look and the first alert that allows a large community of users to have a single point to go in to actually find the problem. So it's a slightly different use case. But you can use Open NMS in that sort of very gnarly individual thing. The trouble is you end up with a configuration that is so complex that it's very hard for people to understand. So that's the thing. Yep.
We actually did exactly that recently. We took the approach for monitoring websites, so multiple vHosts on single machines and things. It is possible to do it.
And you talk to us and tell you how to do it later.
Oh, cool.
Because there are implications because it has to be associated with an IP address. Open NMS's lowest common denominator is always an IP address, but there are a couple of ways around that as well.
So I can demo to you later.
Yeah, cool. Cheers.
Cool.
You mentioned the REST API. What's the primary mode for configuring hosts or whatever it is, nodes in OpenNMS? Like I don't have to do the sort of god-awful Nagios config type thing.
So depends on what level you want to work at. There is a UI, and most things that you do often, you can do through the UI. Things that you do less often, you use XML, and there's XML configs. Now, basically the UI manipulates that XML, and the REST API does the same thing. It manipulates the XML. So XML kind of is the lingua franca for everything to understand what's going on, but the UI gives you a way of manipulating it. Now, what we encourage people to do is to think in terms of how much do you want to discover and how much do you want to tell Open NMS. So in the Swisscom case, they don't want to discover anything. They've got another database that knows every hotel and knows every hotspot, and it just tells Open NMS, and it posts in an XML file through the REST API that gives you the full configuration. Tells it all the services and all the ports and all the devices, and Open NMS discovers nothing. The wind case is another side where all we get told is there is a device, but we will go and discover the device, and we've got a set of policies that say, when we see this device, if it's this sort of device, it's got this number of ports, and the ports are labeled in this way, this is the way you categorize them. So it's a bit of a mix and match.
So if I've got, say, a couple hundred servers in Puppet, they're managed by Puppet, can Puppet use the API, or how does that typically?
Puppet could use the API. I think we've got some examples of that. I think there was a talk, wasn't there?
There's actually a slightly different tool which is called PRIS, which is the
Provisioning Integration Service,
Service.
which is a part of the Open NMS family, but it basically does a mapping between any provisioning stuff and the Open NMS API.
So you could actually query your Puppet database to return the XML in a particular format. So all it does is go to the database, run the SQL query you give it, return the data in a particular format, and then PRIS converts that into the XML configuration file for Open NMS.
Yeah, we've got some examples of that online for people to play with.
It's very, very powerful.
Yes?
Did I understand you were developing your own time series database? And did you look at any of the others that are out there? It's a relatively hard problem.
It is a relatively hard problem. The guy who's actually doing it for us is part of Cassandra's development team. And yes, they did look, I mean, yeah, you know, like yeah, it is so, I mean, the issue is not so much the data storage stuff, because Cassandra does most of that for you. The issue is the metadata associated with that to allow you to use it meaningfully. And so that's where the work has been in Newts, in defining an API and metadata that allows you to, you know, quickly get in and graph that data or pull it out or find out what it is. So yeah, they did look at other things. I don't know what the puts and takes were on that, but you know, that's the route we've gone. Interestingly though, we probably wouldn't go the same, we're doing that for performance, we wouldn't go the same route for logs. So our sort of strategy at this point is to use Elasticsearch just for raw logs. But then when logs are important, we'll generate an alarm, and that'll go through the normal alarm handling mechanism. Yep. There's another one.
So it's semi-related to what this chat is talking about. We're currently looking at trying to find a solution for push-based alerting. The phrase we heard was the ambassador pattern, where the slide you had up where you had this new daemon which was just pushing out its state back to a central server based on whatever's going on within its server. Is that can you get close to that currently with remote collectors? Are we just behind the curve currently?
No. I think that's basically what the strategy is.
You can do that right now with remote collectors, or you have to wait.
Well, yeah, you can.
How much of what you showed there was? How
much is real? Okay, the remote pollers are completely real, but remote pollers basically do synthetic transactions with a view to just telling the response time and that it's up. So it's an up-down kind of thing in response time, limited amount of data going back. That's all real, that works. Remote data collection is about collecting all the data that a device can provide, for which you need to be able to understand the device and do all of the sort of clever stuff around policy on a device. That's the work in progress, for which, you know, it's sort of, I think about 80% there. If you download Sneepo and sort of look at the puts and takes on it. It is under contract for somebody, so we're hoping by the end of the year it'll all be there.
So there's existing functionality you can use to push data through using the REST API. So there's things called is it passive service monitors? So you can push some data through that way.
Yeah, I mean, OpenNMS can accept data from multiple different sources. So if you've got a push source of data, we can send that in as an event, and it'll be handled.
Yeah. You just aggregate essentially. Yeah, it's all happening out. In the specific.
And vice versa, we can publish stuff too. So works both ways.
Is that true of where the centre at Open NMS doesn't know about a node? So is it possible to do sort of cloud-based monitoring where you've got something that pops up and spits a...
Yeah, so if an event pops up and it doesn't know about it, it'll record the event and do something with it, but it'll just say, unknown node. You can decide what you want to do with that in terms of rules. You might create a new node. You might say, oh, here's a new one, right? We've got a new node here. Let's go and find out what it is. Or you just handle it as an event and just escalate it in some way and say, there's something here. I don't know what it is, but there you go. So yeah.
Presumably you could, as part of spawning a node, you could say through this REST API, this is me, here's the information about me, so that when the first event comes through Open NMS.
Well, that would effectively be provisioning a node, but yes, you could, yes. So you would tell Open NMS, you know, basically, you know, the IP address of the node, the name of the node, any other metadata you want to associate it with it, and then when any event comes in, it will be associated with that device. Give it the, you know, where's the geographic location of it, well, that sort of thing. Any more? Thick and fast?
Is there any multi-tenancy capability within Open NMS?
Not really, not, you know.
So if I want to host little chunks of monitoring for various sort of customers, is Open NMS doing anything useful?
It's kind of what you're doing, but
Well, there's kind of support, sort of. I was looking in the config files a while back. There is support in there for doing kind of group ownership of instances, but it's not.
Yeah, I mean, the short answer is you can divide the UI into sort of customer-centric views, but it isn't 100% secure in terms of what somebody might see. So if you've got a trusted set of people you want to see stuff, then yes, you can do that. In a lot of cases, what people do is they use Open NMS as the engine, and then they have a portal on top of it using the REST API. The engine does the data gathering, doesn't care where it comes from, but the portal is the thing that does the, you know, effectively the multi-tenancy stuff that you're talking about. But no, it's not a truly multi-tenanted application. Are we at the end? Great. Well, thank you very much indeed. Appreciate it. Thank you.